Okay, so now this is question number 2, and this is related to group 17. All right, chlorine is a reactive yellow-green gas. It is a strong oxidizing agent. State how chlorine is used in water purification. So this is just a simple question for 1 mark. So why chlorine is used in water purification? It is used to kill bacteria or other microorganisms or microbes. Alright, so basically we use chlorine for water sterilization, right? So it kills bacteria by releasing atomic oxygen. Okay, so the next question is chlorine has the highest first ionization energy of the period 3 elements from sodium to chlorine. Construct an equation for the first ionization energy of chlorine. So we have to write the equation for the first ionization energy. So ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous atom to form 1 mole of gaseous ion. To include state symbols. So I hope everyone knows how to write the ionic equations. So chlorine gaseous atom, it loses 1 mole of electron to form 1 mole of gaseous ion, Cl plus. Right, so this would be the ionic equation for the first ionization energy when 1 mole of gaseous atom loses 1 mole of electron to form 1 mole of gaseous ion. Okay, so the next question is explain the general increase in the first ionization energies of the period 3 elements. Period 3 elements across the period ionization energy increases. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So they're asking that why there is a general increase in the first ionization energy of the period 3 elements across the period, why the ionization energy increases. Because we know this thing, across the period the number of shells remain same, right? Number of shells same. Atomic radius, that means atomic radius is almost same. There is a slight decrease in atomic radius, but that is not due to number of shells. It is due to the nuclear charge. So atomic radius almost same, but what happens is that nuclear charge or number of protons increases. Sodium has 11 protons, magnesium 12, aluminum 13, silicon 14, 15, 16, 17. So the nuclear charge is increasing, number of protons are increasing. And when number of protons increases, the attraction of the nucleus for the valence electrons increases and it becomes difficult to lose electron. So across the period, the number of protons or nuclear charge increases. Number of protons increases. Shielding effect and atomic radius is same, or you can say number of shells are same. So the attraction for electron increases, so it becomes difficult to lose electron. Alright, so across the period the ionization energy increases because nuclear charge increases. The pull of nucleus on the electrons increases, so it becomes difficult to lose electron. Now the next question is the halidines. Halidines are generally represented by X. It could be a chloride or bromide or iodide. Show clear trend in their physical and chemical properties. State and explain the relative thermal stabilities. So what do we mean by thermal stability is that for how long they remain stable when heat is applied, right? So of the hydrogen halides. So we have to discuss the thermal stability of hydrogen halides. For example, we are discussing HCl, HBr, HI. So I hope you know this thing, that the thermal stability, it depends on the bond length or bond energy. And as we go down, the atomic radius of group 7 elements increases. And as the atomic radius increases, the bond length increases. And when bond length increases, it becomes easier to break the bond. So thermal stability decreases down the group. Thermal stability thermal stability decreases down the group. So that means it becomes easier to break the hydrogen halide as we go down. And the reason is the bond energy decreases as bond length increases. So when bond length increases, the distance between the two nuclei increases, so it becomes easier to break the bond. So bond length increases. Alright, so they get less thermally stable as we go down the group. Now, the next part is the halidines react easily with concentrated sulfuric acid. You all have studied the reactions of halogens with the sulfuric acid. The halidines, reactions of halidines with sulfuric acid. The main sulfur containing product of each reaction is shown in the table. Right, so when chloridine reacts with sulfuric acid, we get HSO4, hydrogen sulfate ion. When bromidine reacts with sulfuric acid, we get SO2. When iodine reacts with sulfuric acid, we get hydrogen sulfide. Oxidation of number of sulfur is missing. This column is missing. So complete the table to show the oxidation number of sulfur in each of the sulfur containing products. So we have to write the oxidation number of sulfur. So in HSO4, let me just solve one of them here. In HSO4, now this is a polyatomic ion where the sum of the oxidation numbers is equal to -1. Saying that oxygen, the oxidation state of oxygen is -2, so -2 into 4, -8. Right, hydrogen when combines with non-metals, its oxidation state is +1. So -8 plus 1, so that means what would be the oxidation state of sulfur? That would be +6. Right, so +6 plus 1 +7, +7 -8, that would be equals to -1. So in HSO4 minus, the oxidation state of sulfur is +6. In SO2, the overall charge is equal to 0 because sulfur dioxide is neutral. So in SO2, oxygen is -2 into 2, -4. So sulfur is +4. In hydrogen sulfide, hydrogen when combined with non-metals, its oxidation number is +1. So +1 into 2, +2. That means sulfur is -2. Alright, so the next part of the question is that explain why different sulfur containing products are produced when each of these halidines reacts with concentrated sulfuric acid. So you can see that when sulfuric acid reacts with chloridine, the compound that we get or the product that we get is hydrogen sulfate ion. And when it reacts with bromidine, we get sulfur dioxide. And when it reacts with iodine, we get hydrogen sulfide. So H2SO4 is giving different products when it reacts with different halidines, right? And the reason is that H2SO4 is acting as an oxidizing agent in these reactions, right? First of all, you just have to understand this thing, that in these reactions, H2SO4 is not acting as an acid, it is reacting as an oxidizing agent. And the ability of the halidine to get oxidized increases down the group, right? The ability of the halidine to get oxidized increases down the group. Increases down the group. So that means iodide can be very easily oxidized due to its large ionic radius. It is very easy to remove electron from the iodide ion. And the evidence for this is that you can see that in H2SO4, the oxidation state of sulfur was +6. And in H2S, when it reacts with iodide ion, it converts into hydrogen sulfide and the oxidation state is -2. So the oxidation state, it changes from all the way from +6 to -2. There is a difference of 8, right? And when H2SO4 reacts with bromidine, the oxidation state changes from +6 to +4, right? So there is a decrease of 2, So there is a decrease of 2. So that means iodide can be far easily oxidized as compared to bromide ion. So why we are getting different products? Because the ability of the halidines to get oxidized increases down the group when it reacts with sulfuric acid. Alright, now the next reaction is chlorine reacts with, next part is chlorine reacts with aqueous sodium hydroxide in a disproportionation reaction. State what is meant by the term disproportionation. So what is disproportionation? A chemical reaction in which same element gets oxidized as well as reduced. A chemical reaction in which same element get oxidized as well as reduced. So this type of reaction is called disproportionation reaction. Alright, then the next part is write an equation for the reaction of chlorine with cold aqueous sodium hydroxide. So this is very general reaction. You all have learned this reaction. When chlorine reacts with aqueous sodium hydroxide, Cl2 reacts with sodium hydroxide. There are two reactions of chlorine with sodium hydroxide, with cold aqueous and with hot aqueous. So with cold NaOH, we get NaCl plus NaClO plus H2. Right, sodium chloride and sodium chlorate 1 and water. Okay, so the next part of the question is aluminum reacts with chlorine to form aluminum chloride. Aluminum chloride can exist as the gaseous molecule Al2Cl6. It is a dimer. This molecule contains coordinate bonds. Draw a diagram that clearly shows all the types of bonds present in Al2Cl6. So it is a dimer which forms between two AlCl3 molecules. AlCl3 is an electron deficient molecule because aluminum has only 3 electrons in its outermost shell, so it can only make 3 bonds, due to which it has 6 electrons present in the outermost shell, and we call it an electron deficient molecule. But as chlorine, it has a lone pair available. Let's suppose if this is molecule 1 and this is molecule 2. So the chlorine of molecule 2 will share one of its lone pair with the aluminum of molecule 1, and the chlorine of molecule 1 will share one of its lone pair with the aluminum of molecule 2. So this is how Al2Cl6 forms through coordinate bonds, and this is known as a dimer because two molecules are combined with each other. Okay, then next they're saying that describe what you would see when solid aluminum chloride reacts with water. Name the type of reaction that occurs. So when AlCl3 get dissolves in water, the type of reaction that occurs is hydrolysis. It breaks water molecule, right, releases H plus ions, which reacts with the chloride ion to form HCl. So the type of reaction that occurs here is hydrolysis. Right, the type of reaction which occurs is hydrolysis. When AlCl3 get dissolves in water, we get basically this sort of complex. This we have studied in theory. Plus H plus and Cl minus. Right, so this is hydrolysis, water molecule breaks, and what you would see when solid aluminum chloride reacts with water. So solid disappears, and as HCl is forming, so we can say that misty fumes or steamy fumes produced. Right, so this would be the observation when aluminum chloride dissolves in water. It turns water acidic, it lowers the pH of water, right? So you can also say that it turns blue litmus paper red. Now next question is related to the calculations. 0.02 moles of an element Z reacts with an excess chlorine to form 0.02 moles of a liquid chloride. So what type of chloride are we getting here? A liquid chloride. Alright, the liquid chloride has formula ZClN. This is the formula of the liquid chloride that we get when this element Z reacts with excess chlorine and we have 0.02 moles of element Z. and the number of moles of liquid chloride that we get is 0.020. So that means element Z is in a 1-to-1 ratio with the liquid chloride, right? ZClN reacts vigorously with water at room temperature to give an acidic solution and a white solid. So ZClN, it reacts with water at room temperature to give an acidic solution and a white solid. When excess silver nitrate is added to the solution, this acidic solution, when we add excess silver nitrate to this acidic solution, 11.54 gram of AgCl forms, right? So that means this acidic solution contains chloride ions. Suggest the type of bonding and structure shown by ZClN. So because it forms a liquid chloride, right, and it reacts with water at room temperature to give an acidic solution, so that means the type of bonding is, it is a covalent molecule, right? Because if it is an ionic compound, it would increases the pH value. So that means it is, the type of bonding here is covalent bonding, right? Because we are getting liquid chloride, so that means it is covalent bonding. And through covalent bonding, we get two types of structures, either simple molecular or giant molecular. Because we have a liquid chloride, that means it is a simple molecular structure. Right? Next is calculate the value of N in ZClN. We have to calculate the value of N, number of moles of chlorine. So if you just look at the question here, we are getting 11.54 grams of AgCl, right? When silver reacts with this acidic solution, we get 11.54 grams of AgCl, and whatever is the number of moles of Ag, if we calculate the moles of silver chloride, that means we get the moles of chloride ions, because in AgCl all the chloride is coming from this acidic solution, and in this acidic solution the chlorides come from this when we reacted with Z. Alright, so let's just first calculate the moles of silver chloride. We have 11.54 grams of AgCl. So 11 to convert grams into moles, first we have to calculate the molar mass of AgCl. The molar mass of AgCl is 143.4, and when we divide 11.54 with 143.4, the answer we get is 0.08, right? So this is the moles of AgCl, and we know this thing that what is the, if I decompose AgCl, how many moles of chloride ions would I get? 1 mole. So that means moles of AgCl and moles of chloride ion. The molar ratio between AgCl and chloride ion is 1-to-1. So if I have 0.08 moles of AgCl, that means I have 0.08 moles of chloride ions. So now I have moles of chloride ions which were present in this liquid chloride, and the formula of that liquid chloride was ZClN, right? And the moles of ZClN that was formed was 0.020 moles. So that means if I break ZClN, how many moles of Z would we get? 1 mole of Z and N moles of chloride ions. That the number of moles of ZClN that we have is 0.02, and the number of moles of chloride ions that we calculated is 0.08. So what would be the ratio of chloride and ZClN? That would be 1:4. So that means in ZClN the value of N is equals to 4. The formula of ZClN, it would be ZCl4. 1 mole of Z reacts with 4 moles of chloride ions. Now next, this part of the question is related to alkanes. Dichloromethane is widely used as an organic solvent. CH2Cl2 can be prepared by reacting CH3Cl and Cl2 at room temperature. The reaction proceeds via several steps as shown. So the substance that we have here is CH3Cl. It reacts with chlorine. It is a free radical substitution reaction of alkane, and we get CH2Cl2. One of the hydrogen would be replaced by one of the hydrogen here. We have 3 hydrogens, and in the product we have only 2 hydrogens. So one of the hydrogen atom would be replaced by a Cl molecule, Cl atom. So the reaction proceeds by several steps as shown. So they have given us the mechanism of the free radical substitution: initiation, propagation, and then this final step where 2 free radicals are colliding. So obviously it is termination. So give the name of the mechanism of this reaction. So because this is the reaction of alkanes in which halogen is being added, so this is free radical substitution. Right, free radical substitution. State the essential condition required for the initial step to take place. This initial step, so for this initial step we must need ultraviolet radiations. Give the electronic configuration of Cl. Chlorine free radical. Chlorine has total 17 electrons. So 1s2, 2s2, 2p6, 3s2, those are 2, 4, 10, 12, and then 3p5. So this is the electron configuration of chlorine free radical. Identify the products of the step labeled propagation 2. In propagation 2, what happening here is that we have a chloromethyl radical which is reacting with chlorine. So this chloromethyl radical will break chlorine molecule homolytically, and one of the chlorine will be attached to chloromethyl radical, and we get CH2Cl2. It gains an Cl, so it becomes CH2Cl2. Let me just write it here. So we have this chlorine reacting with CH2Cl, chloromethyl radical. So this bond between chlorine molecules, it breaks homolytically, it regains its electron. This regains its electron, and this chlorine will make a bond with CH. So we get CH2Cl2 and a chlorine free radical. Alright, then next is name the type of the reaction shown in the final step. So in the final step, we have already discussed it, that it is termination. There are total 3 steps of the free radical mechanism: initiation, propagation, and termination. Suggest the identity of another organic molecule that is a product of the reaction of CH3Cl and Cl2 under the same conditions. So in CH3Cl we have 3 hydrogen atoms and 1 Cl. So what they have done here is they have removed one of the hydrogen, and instead of that hydrogen they have attached chlorine. So what we can do, we can remove another hydrogen. It can form CHCl3, right? CHCl3. So we can just simply write here that we can get, instead of CH2Cl2, we also can get CHCl3.